Hello everyone, welcome to Learn Overflow. In this video, we will discuss a LeetCode problem that is a palindrome linked list. Uh, so this is an easy level problem, and we'll see how what should be our thought process behind finding a solution of questions like this. Okay. So the question is pretty short and simple. The question says like given a head of a linked list, singly linked list, they mention it carefully. So there's a head of a singly linked list is given to us and we need to return true if it's a palindrome. If you remember palindrome is something like say there's like three numbers in our array or in our linked list or whatever. So in that, say there's like 1 2 1. So this is a palindrome. So it's like the first number and the last number should be equal, so it's the same. Okay, so it's not three, it can extend up to five. So in that case you need to check for every order, the first and the last, the second and the second last, the third and the third last. So it should go ahead in that manner. So say there are five numbers. So in that case it can go up like 1 2 3, then followed by 2 1. So it's like one are equal and two are equal. See, the first and the last, the second and the second last. So those kind of thing happen. If there are like four numbers is like like two and two are equal, one and one are equal. The same thing. The first and the last, the second and the second last. It doesn't depend on the total length. So that's what the palindrome is. Now, in this case, we are given not a simply like array list or something like that, but it's a linked list given to us. So what's the problem for us to check? We cannot move back. Okay, so there's like nothing moving back. So in that case, what should be our approach? So that's the whole question. Because we can check for that. We can like in normal case we can start from the beginning and we can start from the end, 2 pointers, and keep moving till we don't see they are matching each other or over crossing each other. So that's not a case you can go ahead with a linked list because you cannot move back in any of the cases. So what can be our idea? Okay, what can be our idea? The idea can be, uh, if you need to do that, you can do two three things. Is more or less like you can reach or like break this in two halves. Okay, you can do that by 2 pointers. I will tell you how. So if you either can reverse the first half. Okay, reverse the first half, it means like a one is there and two is there. Fine. In the first half I am talking about, so two will be pointing to one and one will be pointing to null. Fine. So one will be pointing to null. So that's the case you can go ahead with. And or in the other way, you can reverse the second half. Like if you do the reverse the first half, then here is your start and the second start is over here. You keep checking if they are going equal or not. Yeah, and the other case you can go ahead is like you reverse the second half. If you reverse the second half, the first half remains same, like 1 points to two, 2 points to null. And in the second half, it will be like it will be same like this. Here's two, here's one. One will be pointing to two and two will be pointing to null. Okay, so that will be the idea because one here is pointing to null, so we are just reversing on each way. Now that's the whole idea. Now how we should go ahead in finding solutions like this. Okay, uh, so that's our question we have, but there's like a follow-up for us. Like, can we do this in order of n time and order of one space? So when it talks about order of one space, so you need to remember you cannot use a different space like an additional a linked list or additional something like that. But you can go ahead with something that is storing a single node, or that's storing a single value or something like that. We can move with that. So how can we do that? So to reach this half, the first thing we should go ahead with the slow fast pointer. So one is like for each of the for every time we are moving one node in our slow pointer, we should move two nodes in our fast pointer. So what will that happen? That we will be ending up in, like in the second case, we will be after second step we'll be here. Okay, and in after second step we'll be at null. So that's the first point. So once we are at here at this like the start of the second half, fine, and the fast is pointing to null. So we know that we got our second half starting. So within kind of slow fast pointer, we do this kind of thing where on the fast pointer is like goes two step, or the slow pointers move one node at a time. Fine. So In that case, we will end up reaching the half of the linked list, okay, the second half. And now, once we reach the second half, we can now reverse any of the half with our approach. We can reverse any of the half and uh, like skip checking. In that case, what's happening? See, you are not going to the end. Like all the end nodes are not being covered. Okay. Say there are n number of nodes. We are not going to the end of the nodes. Like all the end nodes are not done. So a few steps are remaining, and then the second, like while we are like going on with each of the slope pointer we are going on, why don't we reverse each of the node? Like how do we reverse the linked list? We reverse the linked list by we have a linked list. Say we have a node over here, okay, in a linked list that is being pointing to some other node over here. Fine. Now, how do we reverse? Say we are at this node. How do we reverse? We keep a pointer like at this node, okay, and we simply break this pointer, like break this next node, like the next node pointer, and mark it as null. We mark it as the previous one, or mark it as null, and in that case, we then move on to the next node. In the next node, if we again break its next pointer and mark it to its previous one. Okay, so it's like on each node process. So we are not traversing the node again. So while we are moving in our so first pointer to find the middle of our like the linked list, we can keep reversing our fast hub. I mean, that will be much easier to do that. We can keep reversing our fast hub so that we reach to somewhere our fast hub remains reversed and our second half is like we are done with our second half. So that's the whole idea over here. Fine. Now we need to implement that. Okay, so in the like normal sense, we will simply check like if both the nodes are going same, we'll be finding a solution. So that's the idea. That's the easy idea we can go ahead with. Now, let's do something. Let's me quickly write down the code and then explain it to you again to what we are thinking right now and exactly how our code comes up to us. Okay, so let's do that quickly. Whatever code exactly does over here. Uh, so this is the part I just wrote right now. So what we are doing, we remember this. It's giving the constraints over here. So the constraints are the number of nodes in the list is in the range 1 to 10^5. So it makes sure like there's only one node. Now, if there's exactly one node, do we really need to check for this long to find if it's a linked list, like if it's a for calendar or not? If there's only one node, there's no need to check. We can simply say it's a palindrome for us. Fine. So that's what I'm doing. We are just checking if head.next. Head.next is current head, and dot next will be the next value. If it doesn't have any next value, that's null. So there's only one value in our head, like there's only one value given to our linked list. So we can simply say this is a true. Fine. Now comes to the main logic of this code. What we are doing, we're just checking if we took like three pointers. Okay, these are like why we're taking telling that this order of one space. You can see like we are using three spaces only. Okay, so if we're using three spaces only, so how many spaces? If we use order of three, it's order of one because it's in the order of one. Fine, so that's how we calculate the order. Now we took three pointers. One is slow. We named it as slow, and it's pointing to head. Fast pointing to head, and this is a reverse pointer. It's pointing to initially it's pointing to null. So this one will be helping us with holding the reverse of the first half. Fine. So that will be our idea. Now, what we're doing in our step, we are like checking while fast not equal none and fast dot next not equals none. Why? Because we will be jumping twice with our fast pointer. Okay. So in that case, what we'll do first we'll store our reverse like the pointer to a reverse in a temporary node that is temp, and then we're pointing reverse to slow. Fine, we are doing that, and then we're traversing slow like once, and then we're traversing fast twice. Further, we are pointing reverse to temp. So let's understand this in a like single example. If there's like one and two, okay, so there's like one and two given over here. So what exactly happens to our one two in this case? Um, So in this case, if we have 1 and 2 over here, then the first thing we'll be pointing, say river. I'm just reverse as R, fine. Where reverse is initially null. Okay, so the reverse is pointing to null, and then there's like temp. I'm writing as T. So temp is again pointing to null. Fine. Initially is pointing to null, and we are at this head. So slow is slow dot next. So now like temp pointing to null, and then we're telling reverse pointing to slow. So we are telling reverse pointing to slow now. So why is slow pointing? So reverse pointing to this point because slow was initially pointing to head, right? Now further we think slow equals to slow dot next. Now slow moves to the next pointer, so here is our slow pointer is sitting over here after this line. Now next we're doing fast equal to fast dot next. Okay, fast dot next dot next. Now fast was also initially as head. Okay, fast was initially a set. Now it moves to fast dot next dot next. Why is it pointing to null? Okay, so now fast becomes null, and we then do reverse dot next equal to temp. So reverse dot next. Reverse was initially pointing to the first node because that's where slow was pointing before slow was moved to the next node. Okay, so reverse was pointing. So reverse dot next will be we are pointing it to the temp. So what is temp pointing? Temp pointing to null. So we are just breaking down this linkage, and after breaking down linkage, we are reversing it in the other direction and pointing it to null. Fine. So that's the idea. Now we don't lost track of the rest of the list because slow is still pointing to there and fast is has moved into the next node. Now after this step, can we move fast? Because fast is already null, fine? If fast is already null, in that case, we cannot move this further. So we know that we have two halves ready for us, and next we will check. Uh, I'll come to this a minute later, fine? Then we'll check if reverse is not null. While reverse not null, so reverse is not pointing at null right now. So we'll check if slow value not equals reverse value, return false. So one not equals to return false. Yes, okay. And further, if this false doesn't hold, if they are equal, then what we are doing? We are moving slow to next. In this case, we don't have values, and we are moving reverse to next. Reverse dot next was pointing here, so it's reverse dot next was pointing there. So it's like we are moving reverse to the next, and we are moving slow to the next. We got in the middle, and now we are moving back. Right? And after like checking for all the values, if we find reverse is null, so we are done with all the checking. In that case, what we'll do, we'll simply return true because that we found our target, we found a match, complete palindrome match. Now, there's I left something. It's like fast not equals null. Why we are checking that? Okay, say there are like three values. Okay, say there are three values. So first, like after this, say there was a value like over here called one again. Fine. So after this, fast is currently pointing to this value, and our loop will this particular while loop will break because fast dot next is not equals null. So fast is not null, but fast dot next is null. So we cannot move to a null value. So in that case, like what we'll do, we cannot move slow farther. But is this the middle? Because if we move like this is like what I'm meaning is say 1, 2, 1, fine. Our slow is here, our reverse is here, and our fast is pointing here. Okay, but if we start checking for slow and reverse from this position, it won't match. But we need to move slow to the next position so that like this is an odd number of cases. Like this holds true only when there is like odd number of values or odd number of nodes over here. Fine. So that is the only check we are going on because there's no point checking for two. That's an odd number. We'll check for this one and this one. Fine. Like not the middle value check is not needed because that's anyways in a palindrome. So that's the idea. So this is how our whole code works, and obviously it works in order of n. You understand why it's order of one because we have only fixed number of variables. We don't have a complete linked list, or we don't have a complete value like that. But we have simply uh, like simply single nodes for us. Fine. Now, what exactly we are doing? We exactly have traverse likewise the order of n. Order of n you can understand because this slow dot next. Look at this slow dot next. This one is traversing only like others are moving back, moving forward. Someone is going back forward in 2 steps. Someone is moving back after 2 steps. Okay. So, but this slow dot next is one traversing the whole list. Okay. In that case, we find that this is traversing only once. We are not traversing again and again through the same list. Okay. So that's how it's order of one for order of n as a time. So that's more or less about this video, guys. Also, I missed out this part. Why head dot next is null? Because there's one value, right? We are sure that there will be one value only. Now we got one value, like there can be one value. Further, we are checking if head is currently here. So the normal check that we do is like if head is null or not. If head is null, is not a case because there is no like zero values. Zero nodes are not possible. There is at least one. So we are checking if head dot next is null or not. If head dot next is null, that means there's only one value. If head dot next is not null, that means there are other values. It may be 2, it may be 10 to the power 5, any values, like any number of nodes may be present, but uh, at least if there's like only one value, we are done with this check. So that's more or less about this video, guys. So I hope I can make you understand how you can find a solution or think on finding a solution to this kind of questions. And if you have any doubts or any thing, if you don't understand, make sure to comment them down in the comments below. I'll be happy to help you out in the comments as well. So thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.